Hey everyone, welcome back to the Fortify mold design training series. So today we're going to be doing module 3, so the basics of designing a mold. We're going to touch on everything from selecting your mold block size all the way through actually designing a mold, the core and cavity parts of a mold. So this is going to include everything to get you to that first working mold. It's not going to include a lot of the advanced design features and tools that we use in order to really enhance your molding experience, but it's just going to get you to that bare minimum a functioning mold. So with that, we'll jump right into CAD and we'll get started here. So we're going to start out with the cap part that we used back in module 1. So let me open that up here. So for this cap part, if you guys remember, this is going to be out of a nylon 6/6. So with the nylon 6/6, we have to account for the shrinkage that's going to occur during the molding process, which ends up being about 1.5% roughly. So in order to account for that, there's a couple different ways you can do this, but my preferred method is to actually save this part as a new part or as a copy of the existing part. And in that file name, I like to include the scaling factor that I'm going to be applying to the part. And the reason I like doing it this way is if you want to go ahead and mold your part in a new material, different material that has a different scaling factor, it's easy to go back to your original model and save it as something new. So we'll go ahead here and add our 1.5% scaling. So it's just slightly going to increase the diameter of this part and all the features so that when we actually go ahead and mold this part, it'll shrink down to our target size. So with that, we'll go ahead and open up our master model. Actually, we'll take one step before that. So we'll move this new part into our mold design folder. Okay. Perfect. So what we're doing there is we're moving this part into the folder that we're going to be doing our mold design in. Everything we're doing with this mold design is going to be referenced locally to this folder. So that's why the part needs to be in that specific folder. So we'll go ahead, we're all set there. So now we'll open up our master model. So this is our master model. We went over this in the last module as well, but it just includes all the different features and things that you might need to design your mold that are common amongst both your core and cavity halves. So like we talked about, alignment or mounting holes, alignment pins, your runner location, things like that. So with our starting location here for our part, we'll go ahead and copy the geometry of our part in. And this copy geometry feature, this is a really nice feature that Creo has that allows us to, let me move this window. So it allows us to copy a part, and whenever that part gets updated, we're able to, those updates will roll down into our master and then down into our mold core and cavity. So we don't need to do anything manually. It's all done automatically for us when part designs are updated. So we'll go ahead and we'll select the part here. So just like that, we've copied our part in. So based on the parting lines that we talked about in the last module, this part is not going to be a good orientation. So we'll need to rotate this coordinate system here. So it should be, if we flip our Y and Z, there we go. So now we have our part in position. It's still not quite there. It's not quite where it needs to be, but at least it's got the orientation that we're looking for. So one thing I want to touch on before we get any further with this mold design is for the mold block size that we're going to be using this outline for this mold or for this part itself. What we're looking for is a 10mm wall offset between the part and the block itself. And this smallest pocket size in this master model is going to allow us to achieve that. If we didn't have the requirement of 10mm wall thickness around this part, then we would have to go to a bigger block size depending on what that part dimension might be. But for this mold design purpose, we're going to be able to use the smallest pocket size. So if we look at the side view of our part here, we can see that we're going with this top parting line. So that's how this part is drafted and it's exactly how we're going to design this mold. So we'll have to go ahead and actually offset the part from the parting line itself. We're going to actually do that by creating a new, we'll open the part, we're going to create a new coordinate system within the part. That's going to be the easiest way for us to properly place that part. So you can see right now, the coordinate system we're going with is on the base plane of the part, and we want to add one on the central plane. So we'll go ahead and do a quick sketch to give ourselves some references for this coordinate system. And that should be it. We'll go ahead and add in this coordinate system now by selecting those two lines we just sketched. And we're good to go. So we can come back to this external copy geometry feature. We'll go ahead and update our references. So actually, we'll edit the feature itself. That'll be the easiest way to do this. Let's go here. Okay. Go ahead and select that new coordinate system. Play. That's right. We need to select our part surfaces still. There we go. We'll go ahead and we'll re-edit this so that we can get the proper orientation. Okay. So now we have our part back in position. We'll flip that one more time. I'll explain why we're going to flip this in a moment here. So the reason we just flip this part into this target orientation is because of the core and cavity layout for this part itself. So for this part, we want this thread section. We want that to be on our core. And then this exterior stuff, this little top flange here, we want that to be on our cavity. So for that purpose, that's why we rotated the part, so we're looking at it in this view. So now that we have our part oriented as we would like, we're going to go ahead and actually adjust the position of this part a little bit. So as is, it could be nice to have this part placed over this ejector pin right in the center of what's going to be our insert there, but I would rather center this part a little bit more on the mold block itself. So we'll go ahead and edit the sketch for our coordinate system, our mold master coordinate system. We'll just move this around a little bit. Go ahead and center this on the center line, and we'll actually bring this to the full mold center here. Okay. All right, so this part is now fully centered in our mold block. It's exactly where we want it for our mold design to begin. The last step with this is going to be designing our runner. So we like to design a runner in our master just because it's going to take place on both your core and your cavity section. So it's good to design that in your master model as opposed to in the actual parts. Okay, let's go ahead and we'll edit our runner path sketch. So we've built out our runner path sketch already so that we're able to just adjust some of these parameters and maybe create some new lines, and that'll get us to a fully designed runner system without having to do too much work on our own. So we'll go ahead and we'll add a line connecting the runner to the part itself. And I like to make this line perpendicular to the part. So let's go ahead and redo that arc in a moment. This arc here, and that there. Make sure this arc is tangent. Perfect. So at this point, we have our sketch laid out for our runner system. Now, we can really assign any sort of arbitrary value to this radius or this round here, to this arc, so that we just lock that in place. It's not going to be a huge deal, but if possible, we like to use larger radii on these arcs, just so that the plastic itself doesn't have to take a very sharp turn in the mold. It's able to take kind of a lazier turn, if you will, while it goes into the part. And the last thing we're going to do here is create a slight offset. Yeah, we're going to create a slight offset here between our runner system and the part itself. So this is going to end up being where our gate lives. Okay. Actually, we'll increase that to 1.5. Okay. Oh, I don't know why that. Don't know why that didn't like that. All right. So redo this real quick. Okay. There we go. So we'll finish this up real quick here. Beautiful. Okay. So we have our runner system in place. So the last thing we're going to be doing on this mold master before we go ahead and make our core and cavities is we're going to add in our gate. So we'll do a sketch on our parting line. And for, I would say, a good 90% of our gates, we like to use just an edge gate with a conical shape. That's really going to be the best for really reducing shear at the gate location and allowing plastic to smoothly flow into the part itself. So for different plastics, we're going to use kind of a different, I'll call it an attack angle going into the part. So what this angle is really going to control is how large that gate diameter is on the part itself. So that's important for things like gate vestige, but also the flow of plastic into the part. Depending on what plastic you're using for your part, you're going to change this gate geometry slightly, I would say. For highly viscous plastics with a very low melt flow rating, or filled plastics, things of that nature, we're going to go with a larger gate, something that's close to a 90-degree angle going into the part itself. We're going to sacrifice the gate vestige a little bit in order to improve the actual filling of the part itself and the longevity that the mold's going to have. For plastics like an unfilled nylon, polypropylenes that are lower viscosity, have a higher melt flow rating, that's where we can actually decrease this attack angle so that we have a smaller gate vestige on the part itself. So for this part here, I'm going to go with a 70-degree angle. That's a pretty comfortable angle where we're going to reduce that gate size, but we're still going to maintain good flow. I would say with a polypropylene, you can bring this down to a 60, and with a old TEM, for instance, you're going to want to use a 90. But for this part, a 70-degree angle on this gate, that's going to work well for us. So we'll go ahead and revolve this feature about the center line. We'll merge this with our runner system. 1, 2, boom. Okay, so we can see that the gate itself, it's only going into the bottom half of the part. So the last thing we're going to do here is we're going to add a radii on this top angle. So we'll go with try 1. So essentially what that's going to do is it's going to allow the plastic, instead of hitting a sharp wall at the end of the gate section on this top half, it's going to allow the plastic to kind of angle itself and flow itself into the part, so you don't have any sort of stress buildup at that location. Great. So at this point, our master model is done. We're ready to go ahead and design our part. Okay, so we'll go ahead and open up the mold. We'll start with the core section that we built out in the last module when we set up our template. So we'll refresh everything here. So we can see that our runner section is already merged with the mold. Our alignment pins are already merged with the mold. Our mounting holes are already merged with the mold. What we really need to do is just add in, the part itself to the mold block. So we're going to start out by just merging the two features together. So at this point, our core block is designed. Actually, we're going to add in a couple of radii before we say that. So we'll add a radii on that sharp angle there. And we'll add a radii at the gate location. What these are going to do is just help us further reduce shear. So I'm using 2 millimeter radii in this section and a 0.5 millimeter radii in this section. Those values are completely, customizable depending on what you want for your gate. I like to go with 0.5 radii on the gate just as a good starting point, but you can certainly go larger, smaller, depending on what your needs are. But what that's going to do is just help increase the longevity of this mold. So we have our mold core. This is the basics of it are fully designed. So we'll go ahead and open up our cavity block now. Okay. So we're going to do the same thing with our core block. Everything else is already in position. We'll go ahead and merge the part with the cavity block itself. And our cavity block is now fully designed. So at this point, we have our mold, it's in place, we have our core, we have our cavity, they're designed, but this mold is still not fully usable. So we'll have to get into, in the next module, we'll have to get into actually adding in some advanced features so that this mold block or this mold set can be fully used. But thanks for tuning in, guys, and check back in for module 4.